So here we go again. A bag contains 5 red. I'm dying. Sorry, I had to pause it and drink some water. Okay. A bag contains 5 red marbles and 8 blue marbles. You randomly pick a marble, then return it to the bag before picking another marble. What is the probability that both the first and the second marbles are red? So let's see here. 5 red marbles and 8 blue marbles. I'm just going to figure out the probability for each of the two events separately. So the first time I pick a marble, that's the number of ways I can get what I want, which is a red marble. So there are 5 ways I can choose a red marble. There are 5 choices to choose from. So I would have 5. And how many total marbles do I have to choose from? Because that's the total number of possibilities. Well, I have 5 plus 8. That's 13. That's 13 marbles there. Okay, so that's the first one. But then I put the marbles back, and then I choose again. What's the probability? And it's the same situation. 5 red marbles and 8 blue marbles. That's still 5 over 13. Some people are thinking, wait, why is it not 5 over 8? Because there are not a total of 8 marbles. There's a total of 13 marbles, right? Because I have 8, I don't know why, 8 blue and 5 red. So the total number of outcomes is 13. I can choose any of those 13. I mean, I know that they're blue and red, but we're considering them as different marbles. So like there's 13 possible outcomes. I can choose one of those 13. And there are 5 different ways to get reds. And I'm saying, what's the probability that both the first and the second, so I multiply, and that's just 25 over 169. So this is rather easy, because 5 times 5 is 25. 13 times 13 is 169. And that comes out to be approximately 0.148. So it's not very likely. I mean, that's 14% chance, almost 15% chance if we move the decimal over twice. So there you go for that. I'll do another one in this video. So this problem's a bit more complicated. So what happens here? So let's just read it first. Let's try and make it make sense. There are 5 blue shirts in your closet, 3 red shirts, and 6 white shirts. You randomly select one to wear on Monday, and then one to wear on Tuesday. What is the probability that you wear a blue shirt on Monday and either a white or red shirt on Tuesday? Ooh, we have an or in this case, so something else happens. We're going to do a little explaining here. So the first thing that I'm going to do is I'm going to split these events up between picking a shirt for Monday and then picking a shirt for Tuesday. That's what we did last time. So I'll do that. And then, how many total shirts do I have? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 shirts total. Okay, there are 5 blue shirts. Yeah, 5 plus 8 plus 6 is 14. Yes. So, what's the probability that I'll wear a blue shirt on Monday? Well, I have 5 options for the blue shirt, so there's 5 ways that I could choose a blue shirt. Out of the total number of ways I could choose a shirt, well, we just said that was 14. So that's a probability of 5 out of 14, which is some percentage, but we don't need to know that one yet. So that's the probability that I would get a blue shirt on Monday. So I've chosen a shirt already. I've taken it out of my closet. Let's say that. So now there aren't 14 shirts. There are 13 shirts in there, and suppose that it was blue, because otherwise we wouldn't be calculating if the first one was blue. So we now have one less shirt. This is called a dependent event because what I do there affects the probability of what I have here. So Tuesday is interesting because it's Taco Tuesday. No, Tuesday is interesting because it says and so I know I'm going to multiply like in there either a white or red shirt on Tuesday, a white or red. Now, let's see how many options. This hopefully will make sense. For Tuesday, how many total options are there going to be? Well, we already know that there are going to be only 13 shirts to choose from. I chose one of them already, and we're supposing that it's blue. So that means if I could get a white or a red shirt, how many different ways could I get a white or a red shirt? Well, let's just first think about what's the probability of getting a red shirt. So let's think about that first. So this will be for the red shirt. What's the probability that I would get a red shirt? That's 3 out of 13. That's 3 out of 13. But when I say or, I'm also considering the probability of getting a white shirt. But it's not like I picked a red and then I'm picking a white. It's like, oh, well, that's the probability for getting a red shirt. What's the probability for getting a white shirt instead? So it's still 13 down there, and I have 6. 6 out of, right? Because I have 6 white t-shirts or shirts. Either I have the probability of getting a red, or I have the probability of getting the white. When we say or, we add the two probabilities together. Hopefully that makes sense. Or you could have just thought about it like this: 3 plus 6 over 13. Those are the chances I could get a white or a red. That's adding together. That actually is the same thing. So that will be 9/13. So the probability on Monday to get a blue shirt would be 5/14. The probability on Tuesday to get a red or white would be 9/13. So I multiply those two together to get my total probability. Hopefully that makes sense to you. And here we go. We have 45 over 182, which is approximately 0.247. So 24% chance, almost a quarter, like 1 over 4, 1 out of 4 times you would get that outcome. So there we go. That's what you get. When it says or, oh, I should write that down. When you have or in between two events, you add the two probabilities. That's because the chances increase. Hopefully that makes sense. You want to add those two things together because the chances increase. If you have one or the other, you have more options. If you have one and the other, then you have fewer options. You have to get that case. So hopefully that makes sense. Or, when it says or in between two events, you add the probabilities. When it says and in between two events, you multiply the probabilities. So that's the second part. When you have or between two events, you add the probabilities of those two events. And here we had an and between two events, but the second event had an or in it. So that was kind of interesting because we'd add there, but when we were done getting the probability for the Tuesday, the total Tuesday event, then we would multiply because it said something on Monday and something or something on Tuesday. Hopefully you can distinguish between those events and what one you add and what one you subtract. So, multiply. And that's it. Good day.